Good morning students. Here we see about the circuit and devices lab 24 EC 202L. Okay, the first experiment. Totally we have a 12 experiments. First we see about the first experiment, that is verification of KVL and KCL. So first we see about verification of KVL. Okay. So here see about that experiment, verification of KVL and KCL. Here we put it as a 1A, that is the first one, verification of KVL. Second one we go for the verification of KCL. So what's the aim? To verify the KVL, that is the Kirchhoff voltage law. So KVL is nothing but Kirchhoff voltage law. Okay. So here the apparatus required. What are all the apparatus we have to do? Right, so this is the tabular column. In our observation we have to do for the same work. Right, here the name of the equipment, type, range and quantity. Okay, right, quality we have to put. So the name of the equipment, regulated power supply, there is a DC, there is a 1. Then resistance, so we have to put the what all the resistor we have to record, that we have to put that. Then breadboard 1, then for the voltmeter, range is 0 to 30 volt. Then we have to connect the process, means we need some connecting wires, we have to put the connecting wires. So see here, see this is the RPS, that is a regulated power supply. This one is the voltmeter, there is a 0 to 30 volt voltmeter 1, then the voltmeter 2, then we go for voltmeter 3, then finally this is the breadboard. So already we know the color code system, isn't it, for the resistor. So the first one for the resistor, then the second, then third resistors are available. These are all the components. So now we see about for the concept of the voltage law. So what's the voltage law? Sum of the voltage rises, that is equal to sum of the voltage drop, is nothing but if we have the total voltage 20 means, so if we add the total resistor value, there is a particular resistor voltage will be dropped. So if you add the total resistor value means it gives the total voltage. Okay, so sum of the voltage rises equal to sum of the voltage drop. Right, so now we move on to the circuit diagram. Right, so this is the circuit diagram. So circuit diagram, we see the first resistor R1 is the 270 ohm, then 560 is the R2 second resistor, then third resistor 220. So here the we have to connect it for the voltmeter 1, voltmeter 2, then the voltmeter 3. So total circuit will be connected to the RPS. So this is the overall circuit diagram. So here see the tabular column. Tabular column R1 we have the first resistor 270, R2 we have the 560, R3 we have a 220. Right, so here the 270 ohm, this is the first R1, then the 560 ohm we have the R2, then the R3 220. So total voltage equal to what is that? So we have to fix the RPS voltage 20 volt. Okay, so 20 volt. If we add the voltage drop across the first 270 means we get the result 9.5. Voltage across for the resistor, there is a V2, we get the value 2. Then the V3 voltage across for the resistor, that is a V3 is the 8.2, we get the results. Finally 9.7, approximately 20 volt. So that's why here we have the calculation. Sum of the voltage rises, there is a RPS equal to 20 volt. Then the sum of the voltage drops. So total, if you add the total resistor value means we get the result also the 20. So equal. So here 20, here also the 20. That is the verification of the Kirchhoff voltage law. We have to satisfy. So now we move on to the experiment. Right, here first we see about that for the, this is the breadboard. Already I explained, no? See here, this is the breadboard. So how we can connect for the breadboard of operation, breadboard connection. So here see, here RPS is available, here the 0 to 30 volt, this is the RPS, we know, right? Here for the plus, here this is the plus, that is the positive one. So you take first for the positive, RPS positive, just to take. So here we have a vertical connections. So always breadboard having the vertical connection, I have to put the insert the wire here, right? That's the positive, first RPS. So RPS is the, here RPS, so RPS plus, so the positive value is connected to the breadboard in the vertical value, right? Then so what is the second connection? That is this pluses move on to the where 270, and also V1 voltmeter, first V1 plus is connected to the particular RPS under 270. Okay, so now we have to connect. I have to put the 270. So here see, just here this point, right? So plus then this point, no, so we have to insert the resistor for the connections. Okay, see, so the first RPS plus is connected, then I insert the 270 ohm. So what is the third connection is there? V1 positive also here connected, so I have to take V1 positive, right? So first voltmeter here also is connected to the same vertical section, right? We have to insert, right? So have it clear? So this is the first RPS plus, so that is a plus. Then we have a 270, so 270, so resistor is connected, then this line also plus is there, so this point, okay, so we have a plus, so V1 plus will be connected, right? Next, what is the second case? So for the end of the resistor we have a we have to consider as a point. So 270 resistor and voltmeter V1 negative and the 560 and V2 positive are connected. So now we see, just this is the 270, so 270 is end, so 270, so we have to connect a point. So this is the 270 A point, this is the A point. So 270, this is the A point, right? A point. So what are all the values are connected? First one is 270, resistor is connected here. Okay, next we have to connect the V1, first voltmeter negative point. So first voltmeter negative point we have to connect it here, right? I have inserted, right? So second, so first 270 is finished and the voltmeter 1 negative is connected. What is the second one? So 560 resistor and V2 positive we have to connect it. So I have to take V2 positive in the same A line, A point, okay? So I have to connect it here. Right, I have inserted for the V2 positive, this one finished. Then I have to fix the 560, right? So here also I have to put the 560 in the A point. So that's all for the second case. Okay, right, 560 finished. Then we go for the third circuit. This is the B point. So this is the 560, that's a B point. So now from the B point we have a 220 ohm is connected, and for the voltmeter V3 positive is also connected. So I have to take, and also V2 negative is there. So here V2 negative and V3 positive, then 560, then 220. Now I have inserted 560 end of the resistor. Now I have to move for the V2 negative. So V2 negative is connected here, inserted, so it is finished. Then we go for the V3 positive also. So the same point, V3 positive also. So I have inserted V3 positive. Then we move on to the, we move on to the 220 ohm. So 220 ohm I have to fix. So V3 negative connected. Then we go for the 220 resistor, right? So 220 resistor I have inserted for the safer side here. Right, okay. So next see the circuit, right? So from the 220 is connected here, the V3 is connected to the negative point for the 220 end. Then the total 220 is connected to the RPS negative, okay? here V3 negative is connected here, 220 end of the value. Then here also RPS negative also connected. Okay, that's all about the circuit. Okay, here the 270, 560 and 220 are connected. So now we have to switch on the RPS. So I have to put the value just for 19.8 because RPS we have to take for the 20 volt, no? So nearby I have to put 19.9. So see the reading, see the first voltmeter reading. Here we have the value 9.5, right? 9.5. V1 is the 9.5. See, so first value is 9.5. See the V2 having the nearby 2, exactly 2. Okay, so if you take 2.1 also, right, we have to put 2. Then we go for the V3 ammeter. We have a nearby 8 point, right, that is a 8.1 or 8.2. Okay, nearby. So now see the table. So first one 9.5 from the voltmeter, second one is the 2, third one is the 8.2. so we have to add the total voltage value. So 9.5 plus 2 plus 8.2, we get totally 19.7, approximately 20 volt. Now the Kirchhoff voltage law satisfied. So whatever the value of the sum of the voltage rises, and that is equal to sum of the voltage drop. So finally we get the result is the 20 volt equal to 20 volt. So if we have for the theoretical calculation, so see here total voltage is the 20, R equal to R1 plus R2 plus R3. Then what are all the values we have here for the 270, 560 and 220. So if we do the some calculation, we get the result for the 20 volt. Thank you. Good afternoon students. For the theoretical calculation, so if we have the value R is equal to 270 and second R2 is equal to 560, third R3 is equal to 220. So those values from the circuit diagram itself we have to calculate. That is a 270, 560 and for the 220. So now we have the total voltage V is equal to 20 volt. So we have to add the three values 270, 560 and 220. So total we have a value 1050 ohm. So I is equal to V by R. So 20 divided by 1050, so we get the value 0.0190 ampere, right? So if you want to calculate the V1, I into R1, voltage drop across the R1. So for V1 equal to I into R1. So 0.0190 into R1, first resistor 270, we get the value 5.13. Like that V2, I2 into R2, then 0.0190 into 560 equal to 10.64. Then V3, I into R3 equal to I value into resistor value 220, so 4.18 volt. So finally V is equal to V1 plus V2 plus V3. So we have to add the three values 5.13, 10.64, 4.18. So finally 19.95 volt. This is the theoretical calculation. Right here for the tabulation itself we have the resistor value 270 and the 560 and the 220. We get the value 19.7. So these are all the final value of the verification of KVL. Thank you students.